Yes, during last video lecture, we are discussing about volumetric strain of a rectangular body subjected to uniaxial load. From general equation, we know that the volumetric strain is epsilon V equal to epsilon x plus epsilon y plus epsilon z. So, and we have seen that the load is uniaxial load and it is acting parallel to x-axis, perpendicular to the plane by yz plane, and we will find the changes in dimensions of this length, breadth and height. Epsilon x, the longitudinal strain along x-axis due to sigma x. Due to sigma x, the value epsilon x is given by sigma x by E. It is the first equation. It is a primary strain, primary linear uh, or a what we call a linear strain, a primary or a linear strain, or a longitudinal strain. It is the longitudinal strain as it is given here. Longitudinal strain epsilon x is sigma x by E. Now epsilon y is lateral strain along y axis due to sigma x. Epsilon y is a lateral strain, and we get the expression for from the Poisson's ratio. Mu is equals to minus of epsilon y by epsilon x, that is longitudinal strain. So epsilon y is equals to minus of mu into sigma x by E. This is the second expression. So epsilon z is lateral strain along z axis, say minus mu into sigma x by E. It is the third one. Now epsilon v is given by epsilon x plus y plus z. The final expression we got is sigma x by E into 1 minus 2 mu. Now the same volumetric strain of a rectangular body subjected to biaxial load. When the applied load is biaxial, it is Px and Py. Because of this Px, we will get the changes in all the dimensions. In x direction, you will get the changes like increasing in dimension. In x direction, it is increasing because of Px, and in y and z directions, the dimensions will decrease. That is the lateral strain. Now, because of Py, the y direction, in y direction, the dimension, that is h dimension, will increase, and the dimension in x and z direction will decrease, because the lateral and longitudinal strains are opposite in nature. Because of this Py, the longitudinal strain causes change in h, whereas the lateral dimensions b and l will decrease. So it will, h will increase, l and b will decrease. Because of Px, x will increase, and h and b will decrease. Here h and b will decrease. Because of this P, l increases, b and h decreases. Because of this Py, h increase, l and b decrease. The dimensions of the plane formed by x and z, or the dimensions of the normal to the applied load, will decrease. It is a lateral strain. It leads to the lateral strain. Whereas the along its direction, if you find the changes, it is a longitudinal strain. Now, for this body, the given body, a cuboid or a rectangular prism, for this body, we are having two loads, Px and Py. Because of Px, we are having sigma x, and because of Py, we have sigma y. When such type of two loads are acting, we call it as biaxial load. And we are going to find expression for volumetric strain of a rectangular body subjected to biaxial load. For biaxial load, from general equation, the volumetric strain epsilon v is equals to epsilon x plus epsilon y plus epsilon z. So epsilon x is equals to linear strain, that is linear strain, epsilon x linear strain, and epsilon y and epsilon z are lateral strains. With respect to this px, now we will see. In x direction, very important. In x direction, the dimension we have is L. The changes in L is because of Px and Py. We will find the changes in L because of that Px and Py. Because of Px, it is a direct primary strain, but because of Py, it is a lateral strain. In one, because of Px, it is increasing, L is increasing. Because of Py, it is decreasing. So just it is a physical observation, that's it. Both sides, if you are pulling in Px, this L direction will increase. In Py, the L direction should decrease, because these two are opposite here. Partly they are opposite. So that's why we get an expression for epsilon x is linear strain due to sigma x plus lateral strain due to sigma y. He is speaking, strictly speaking, only in x direction, that is change in L. What he is speaking is change in L. So linear strain due to sigma x, lateral strain due to sigma y. Now sigma x by epsilon minus mu into sigma y by E. Lateral strain due to sigma y is that is Py. Actually here you should write Py instead of sigma, you should write Py. The strain due to this load Py is, again this is from the Poisson's ratio mu. Again we will see how the relation goes here. The Poisson's ratio mu is equals to minus of lateral strain by longitudinal strain. Lateral strain is equals to minus of mu into longitudinal strain. So lateral strain along lateral strain, fine. Now so we should remember this one, and we come here again mu into so it is the Poisson ratio is equals to lateral strain by longitudinal strain. Lateral strain is equals to, see, this is what we want. Because of this Py, we have sigma y is induced, and epsilon y is given by minus of mu into the primary strain sigma y by E. But it is with minus sign here, because both are opposite in nature, so it is with minus sign. So epsilon x is given by sigma x by E minus mu into sigma y by E. This is the first one. Epsilon y is linear strain due to sigma y plus lateral strain due to sigma x. Linear strain due to sigma y. So I want next epsilon y changes in the dimension, that is h dimension in y direction. Because of this Py, h will increase, but because of this Px, h will decrease. But because it is a lateral strain with respect to Px, longitudinal strain with respect to Py, as mentioned. So we again, as discussed in the first case, first equation, it is same, sigma y by E minus mu sigma x by E. So this expression again, it is from the Poisson's ratio mu is equals to minus of lateral strain or secondary strain divided by longitudinal strain or primary strain. When we are having these two loads, we get two biaxial loads, we get the expressions like this. Now epsilon z, the lateral strain due to sigma x plus sigma y. Lateral strain due to sigma x and sigma y, both for px and py, because we don't have a another load in z direction, so there is no the other term, that is primary strain in the direction of z. We have only lateral strain in the direction of z. So lateral strain is given like this: minus of mu into longitudinal strain in x direction, minus of Poisson's ratio, so minus of Poisson's ratio into the longitudinal strain in y direction. So when you give these two, and we get an expression, third expression, and when we add the equation 1, 2 and 3, we get an expression sigma x by e minus mu sigma y by e plus sigma y by e minus mu sigma x by e minus mu sigma x by e minus mu sigma y by e. Take the commons outside. Sigma x by e, here 1, 2, 3. So 1 minus 2 nu plus sigma y by e, here we have sigma y by e, 1 minus sigma y by e, sigma y by e, so 2 mu. So epsilon v is equal to sigma x plus sigma y divided by e into 1 minus 2 mu. So this is the expression for volumetric strain when a body, a rectangular body, is subjected to biaxial load sigma x plus sigma y by e. So we can separately we can write this term as directive strain epsilon x plus directive strain epsilon y into 1 minus 2 mu, where mu is the Poisson's ratio, or it can also be written as 1 by m, that is 2 by m. Here it is, when it is 2 is multiplied by here. So delta v by v, again epsilon v is equals to delta v by v is equals to sigma x plus sigma y by e into 1 minus 2 by m. Similarly, we are having the volumetric strain of a rectangular body subjected to triaxial load. Triaxial load means we are having px, py, pz. Both all the surfaces or all the directions, x direction, y direction, z direction, are subjected to the loads. One is in x direction you are having px, in y direction py, z direction pz. Because of this directive forces, these normal forces, the stresses induced are sigma x, sigma y, sigma z. They are normal stresses, tensile stresses, normal and tensile stresses. Because of these tensile stresses, you will be having primary strain along x direction, primary strain along y direction, primary strain along z direction. Because of this px, you will be having lateral strain in y and z direction. Because of this py, you will be having lateral strain in x and z direction, and due to pz, lateral strain along x and y direction. So when we consider all this, then we get the expression for ev epsilon v. So epsilon x, same, epsilon v is equals to epsilon x plus epsilon y plus epsilon z. Epsilon v is equals to epsilon x is equals to linear strain due to sigma x plus lateral strain due to sigma y and sigma z. Sigma x by e, because it is inducing the lateral strain also, that's why we add all the two. Sigma, because in x direction, that is this length is affected, this length is affected by this px, py and pz. Px it is direct, py and pz it is lateral. So because of this py, sigma mu sigma y by e, and that pz mu sigma z by e. So this is expression 1. If you have understood this first expression, the other two expressions are similar to the first one. So what is happening here, it is the the primary strain minus secondary strains. Primary strain, it is a pulling strain here. The secondary strains are compressive strains. So we have the effect of these two, minus of mu sigma y by e minus of mu sigma z by e. Similarly, epsilon y, linear strain due to sigma y plus lateral strain due to sigma x and sigma z. So epsilon y is given by sigma y by E. This is longitudinal or linear strain due to sigma y minus of lateral strains, that is sigma x due to sigma x and sigma z, mu sigma x by E minus mu sigma z by E. This is the second expression. Similarly, epsilon z, the strain or the changes in the dimension of this B is given with the linear strain due to sigma z, that is linear or longitudinal strain, better we can say longitudinal strain or primary strain due to sigma z, lateral strains due to sigma x and sigma y, sigma z by E minus mu sigma x by E minus mu sigma y by E. This is the third expression. When you add 1, 2 and 3, we get the final result like this: sigma x by E minus mu sigma y by E minus mu sigma z by E plus sigma y by E minus mu sigma x by E minus mu sigma z by E plus sigma z by E minus mu sigma x by E minus mu sigma y by E. Now, when we separate the terms, we get the sigma x by E. We have here sigma x by E, the second term, it is with mu, and sigma x by E is also with mu. So it is sigma x by E into 1 minus 2 mu plus sigma y by E into 1 minus 2 mu plus sigma z by E into 1 minus 2 mu. So when 1 minus 2 mu is taken common, we get sigma x by E plus sigma y by E plus sigma z by E. These three are the primary strains: epsilon x plus epsilon y plus epsilon z into 1 minus 2 mu, or you can write in this form also: sigma x plus sigma y plus sigma z by E into 1 minus 2 mu. So if yeah, this equation holds good for compressive loads also. And there is one more simple topic: the volumetric strain of a cylinder. There it is for a cuboid, it is over. Now it is for a cylinder. A general application is seen for a cylinder. How we will do for cylinder? There is a cylinder with a diameter d, length L, egg in x, y, z. This axis is shown here. So along x direction, we are having a normal force, tensile force, which induces tensile stress sigma x. We will find change in L. L will increase, diameter will decrease because of the application of the load, because we are discussing about the bodies which are under deformation. The volume of cylinder, it is pi by 4 d square L is the volume of a cylinder. Here length is a variable, d is also a variable. That's why, because as per the definition, it is del v by v is the change in volume, dv by v, or del v by v is a change in volume by volume. It is epsilon v, strain in volumetric strain. Now volume of cylinder pi by 4 d square L, del v is given as, you differentiate this one, del v is the volume of cylinder, del v is equals to 2 times of d pi by 4, 2 times of d into del d into L, plus as length is also the variable, so pi by 4 d square into del L, and we get epsilon v is del v by v equal to pi by 4. So you just divide by the volume, it is pi by 4 d square L. So pi by 4 will gets cancelled. The remaining is 2d into del d into L and t square into del L. So just cancel the terms whatever are similar, and we get a final expression like this: epsilon v is equals to 2 times of del d by d plus del L by L is equals to epsilon v del L by L minus 2 times of del d by d. So del L by L is that is primary strain minus 2 times of secondary strain. See, length, the change in the length is because of primary strain, that is direct stress, and change in diameter is lateral strain, it is because of the secondary strain. So there are two nodes given. Due to decrease in diameter, so it is taken as a negative sign. The diameter is decreasing, that's why it is a negative sign. Here it is not positive, there it is shown positive, but decrease in lateral dimension, so it is negative, should be taken. And the volumetric strain is given by, here what he says is strain in length minus twice the strain in dia. That is a volumetric strain. And we will continue the session in next lectures. In next lecture, we will see what is bulk modulus and the modulus of there. Some relations are there. We will see what are the relations and bulk modulus in the next lecture. Thank you.